Hi, my name is Enhao Zhang. Today, Maria and I will be presenting our demo paper, Equivocal Demonstration, Synthesizing Video Queries from User Interactions. Video data management systems have received increasing attention from the database area in recent years because it's getting much easier to collect and store large amounts of videos, and also the advances in computer vision has brought up many new techniques to help people understand the video contents. And among these many applications in video analytics, one interesting problem is to study how to enable users to express complex queries over video data. So consider a traffic analytics application. A traffic engineer may want to study road hazards involving car and motorcycle interactions, such as a motorcycle swerving abruptly in front of turning cars. And in the ecology fields, scientists have collected videos of wild animals to study their behaviors and complex activity patterns. So for example, a scientist may want to find video segments where a deer was grazing, then set it a predator, and finally begin running. And how could we find complex events from videos? One option is to use a computer vision model to identify or target events from videos. And there are already many computer vision models that can detect common objects or common activities. However, a specific classifier that can identify the desired user events is unlikely to exist. And if the user wants to train a custom model for such events, they have to go through a tedious and time-consuming labeling process. And from the database community, there are also many great systems that can support such use cases. And they allow users to express a query by sketches or by using Python programs. But it is actually hard to express such queries in the first place. It requires the user to be familiar with the language in order to express such queries. And even worse, real-world events can be difficult to express declaratively, even for experts. And to address these challenges, we propose a new system called Equivocal. And the main idea behind Equivocal is that we want to synthesize queries on users' behalf. So we don't ask users to express a declarative query manually. We don't ask them to provide a large number of labeled examples in order to train custom models. And what Equivocal does is to synthesize queries automatically for the user and from only a few labeled examples. And to use Equivocal, the user comes to the system with an event of interest in mind. And keep in mind that the user never has to write down their events of interest. And the user has to provide a few labeled examples, and Equivocal will eventually output some synthesized queries. And to synthesize queries, the user also needs to provide some user-defined functions, and we will use these functions to extract semantic information from videos. And Equivocal also wants to minimize user efforts, and the system doesn't ask user to provide all examples in advance. And instead, we do it iteratively and ask the user for more labels during the query synthesis process. And finally, the synthesized queries can be used over unseen videos to find more matching segments. Equivocal uses spatial temporal scene graphs as its data model. And in a scene graph, we use nodes to represent objects and edges to represent relationships between objects in a video frame. And here we want to find video segments where a car arriving from the left and passing a motorcycle at the intersection. And one possible way of expressing this query is to use a sequence of two scene graphs. So in this first scene graph, we have two objects, a car and a motorcycle. And then we have these left off relationships to indicate that the car is on the left of a motorcycle. And we also have attributes on the car object to indicate that the car is at the bottom of the scene. And the second scene graph is similar to the first one. except that now the car moves to the right of the motorcycle. And here we also have the cleaning operation around the scene graph to indicate that a scene graph can persist for several frames before moving on to other scene graphs. And there's also a sequencing operation connecting the two scene graphs. And this means that the first scene graph happens before the second scene graph. And equivocal materializes the scene graph from each video data, from each video using user-defined functions, and then synthesize queries as a composition of extracted scene graph atoms. And with scene graphs as our data model, equivocal then propose a new query synthesis approach that can find users' intended events using only a few examples. And it can work on noisy, large radio scale data and also on complex events. Equivocal reduces computational efforts by limiting query search using scene graphs, by pruning search space using beam search, and by avoiding expensive database operations. It also reduces user efforts by leveraging active learning and by being robust to noisy data. And now I will show a quick demonstration of equivocal. Equivocal is a system that helps users to find complex events from their video collection by synthesizing queries from user feedback. The user comes to the system with an event of interest in mind. And suppose the user wants to find video segments where a purple object is far away from a cyan object, and then they move near to each other. And when using equivocal, the user never has to write down their event of interest in the form of a declarative query. The user needs to provide a small number of initial positive and negative examples of the event they are looking for. And next, the user interacts with equivocal by labeling system-selected video segments. And as the user labels video segments, equivocal will update the top-K queries after every iteration. And for the demonstration, we also show the query prediction results on a test dataset containing 100 video segments with ground truth labels. And the border color of each video segment indicates whether the prediction is correct. The user continues to provide more labels. And once terminated, equivocal returns the final top-K queries. And the final query can be used to process the entire video collection to identify all matching events. And equivocal's goal is to generate queries with high F1 score. Equivocal is part of our larger vocal system, which supports end-to-end interactive exploration and compositional query processing over videos. And another component of Vocal is Vocal Explorer, which is a system designed for interactive video data exploration and domain-specific model building. Vocal Explorer targets videos from domain without existing pre-trained models. A user can use Vocal Explorer to explore their video collection and quickly build some high-quality domain-specific models. And after that, the user can provide these models to Equivocal as user-defined functions to further help them find interesting complex events. And now, Marine will show a demonstration of Vocal Explorer.
Vocal Explorer is a tool for video exploration, labeling, and model building for data without an existing pre-trained model. If we look at the videos we have collected, we can pre-filter on metadata. We can also select any individual clip and label it by dragging on the timeline. If we go to another page, we see a lot of similar video clips. If we keep looking, we can find another one that looks interesting and label it as well. Paging through all of these videos quickly gets tedious. So, on the Explore pane, Vocal Explorer automatically samples videos to effectively build a domain-specific model. In the backend, Vocal Explorer provides three main features. First, each operation is interactive. There's no blocking. Second, the system automatically determines the right representation to use for the video data when training models. Finally, it samples data efficiently, only using more expensive active learning methods when needed. As soon as we have labeled a few videos, the system also shows its own predictions. We'll label a few more videos to try to improve the model's predictions. After labeling just 10 videos, we're already building a pretty good model that can find examples of the deer foraging. We'll search over the model's predictions and use a confidence value of 0.8 because the model hasn't been trained on many labels yet, so it may not be 100% confident. For example, in this clip, initially it looks like the deer is bedded, but we can see that partway through, the deer is indeed foraging.
In conclusion, we propose and demonstrate Equivocal, a system that synthesizes compositional queries from user examples. Equivocal is part of our larger Vocal system, and another component of Vocal is Vocal Explorer, and in this talk, we also demonstrate Vocal Explorer.